Thanks, Rachel. Good morning, good afternoon, and good evening, everyone. Thanks for taking time off your day and joining us on this webinar titled Deliver Efficient Machine Learning with NXP's i.MX 9 Applications Processor and iWave's IW Rainbow G50M System on Module. So, my name is Tawfiq Ahmed, and I lead product marketing for the System on Modules at iWave Systems and in terms of delivering the product market fit. So here's what we will cover over the next period of next 45 minutes. So a quick introduction of iWave and then follow through on why a system on module based approach can help you on your product design and why standardization might be the right fit. And then an in-depth overview of the i.MX 93 applications processor from NXP. And then we go over the features of the system on module, the evaluation kits and their availability, and then spend a bit of time on the OSM standard, which is a new standard for system on modules, and how do you design a product with the OSM standard system on module. So a quick background about iWave. So who is iWave? So iWave was established in the year 1999 and primarily driven by the mission to be your global embedded technology partner. So over the last 24 years, we have built significant amount of embedded expertise over hardware, firmware, mechanical, and have helped companies in their embedded product development over the years. So we have a global footprint with the engineering headquarters in India and a sales footprint across the globe in North America, Germany, Japan, and Korea, and growing day by day, serving global customers. So as a company, we are focused on the industrial, automotive, medical, and avionics vertical market, where the primary focus in terms of product longevity, we ensure 10 plus years of product longevity for all our products and a strict focus on quality, reliability, and longevity. And at iWave, we are driven by a key value of having a technology ecosystem and strategic partnership with customers and various uh, ecosystem players across the globe, and also have a very well established distribution and certification ecosystem, which I'll touch upon the next few slides. So this is a key business strategy slide for iWave. So we as a core competency, we are focused on ARM and FPGA, embedded design, system design, hardware, firmware, software, mechanical. So a complete embedded design block, and building on the core value proposition of strong R&D focus with a continuous cycle of innovation as days goes past, the key partnership with NXP, and having a very well established EMS ecosystem across the globe. And a key business unit or a product portfolio, what we call it as this on the system on modules, where we are going to spend a more amount of time in this webinar. So just going a bit deeper, so why a system on module? So there are primarily six key factors which drive a system on module based product approach and has been the recent trend across the industry. So first, it helps you build scalability on your product as technology keeps evolving day by day, and you want your products to be the latest technology. The system on module based approach helps you design such a product which helps you keep in terms of technology. The second is in terms of product development cost and risk, and as well as go to market. So a system on module approach, iWave takes the responsibility of building the complex system where we can help you in terms of building the heart of your product and you enable you on the career card design. So you can help you focus on your core competency and go to market faster. The second is in terms of product longevity. So iWave takes the responsibility of a system on module in terms of the end of life, the software maintenance, the components maintenance. So we make sure that the system on module as a key component. So instead of you looking for hundreds of components by your supply chain, you look at iWave as a key supplier for a single component block where we take care of the processor, the memory, and the key building blocks. And last but not the least is in terms of supply chain and sourcing complexity, which has been the key word in the last 3 to 4 years. So iWave takes the responsibility of maintaining a good relationship and maintaining a continuous forecast and supply of these modules, which helps you focus on your production, your go to market, and your core competency. And now there are various system on module form factors, proprietary modules, proprietary form factors, but why go for a standardized approach? This is primarily because of 2 to 3 reasons. One is we give the system on modules to hundreds and thousands of companies in these standards. So we are able to easily adopt to the field requirements in terms of the field issues. So you have a trusted product. The second, the standardized system on module helps you with a much more performance and commercial competition among suppliers. So you're not bound with one particular supplier. You have multiple suppliers such as iWave, and which also ensures performance and commercial. So you get the best of technical and the best of commercials. So that's the one of the key advantage when you go for standards such as the SMARC, Q7, and the OSM standard. SMARC and Q7 have been a trend for the last couple of years, and OSM was just introduced in 2022 and is looking as a key trend going forward. So why OSM, and why you might have to choose an OSM? It's primarily because of these 5 reasons. So an OSM standard defines a compact solderable module which can be plugged onto the carrier board just as another IC, and offers you a much more compact form factor when compared to the other modules. It offers you a lot of robustness and compactness. I will touch upon the OSM standard a bit more in detail towards the later part of the webinar. And iWave has been a key partner of NXP over the years and have enabled over 900 plus product designs with an extensive portfolio, as you see, starting from 2007. So starting from the i.MX 27 to having the i.MX 15, the Q7 form factor, to the i.MX 8 in SMARC, and the OSM which launched in 2022. So we have had a very good extensive portfolio of system on modules, single board computers, as well as ODM design services. So as you see in the next slide, we have an extensive portfolio whether starting from the i.MX 6 ULL in the SODIM, or the i.MX 8 in the Q7 SMARC, and the SODIM starting from the i.MX 8, the i.MX 8M, the 8M Plus, and where we have just now recently launched the i.MX 93 in the OSM form factor, and also coming soon is in the SODIM and the SMARC form factor, and also the i.MX 91. So all these products, we ensure product longevity and availability up to 2035, and these are standard SKUs, and where we enable companies with these sort of building blocks. And now I hand it over to Robert for a deeper insight into the i.MX 93.
Robert, you're on mute right now. We can't hear you. Robert, are you there?
Okay.
Okay, go, Robert.
All right. Yeah, I couldn't get myself off mute. So thank you, Rachel. Thank you, Tafiq. So for those of you that are familiar with NXP, for those of you that are not, a very quick reminder or introduction. We are a very broad semiconductor company that play across many different markets, as you can see here, from automotive, mobile, communication infrastructure, and the industrial and IoT markets, which we are going to focus on today, as those are the markets that we work and focus on with iWave. If you look across these markets, what is common across all of them is that they need a range of high performance microcontrollers or processors. Those core elements have to be connected, and they have to be connected in a secure way. So even though we play across these very diverse markets, we find that we have a common set of parts that are applicable to many of them, as the needs of these very diverse markets actually begin to converge from what is needed from a core processor standpoint. So what are the parts that we deliver and work with iWave on for the industrial and IoT market? Well, if we go to the next slide, thank you very much. You can see that we have a very broad portfolio. In fact, we have the broadest portfolio within the ARM market today. This ranges at the very low end from the ARM M0 Plus, which we use in devices which can run on a coin cell battery for months, if not years, or even can be designed into digestible medical products. At the other end, we have our Layerscape range of application processor, which focus on networking capabilities, but are also driving the next wave of 5G rollout, depending on where you are in the world. If not, it's already been rolled out, and really look at how they can progress the networking world. What we are going to focus on today is our range of i.MX application processors that are very widely used across the industrial, IoT, automotive, and also consumer markets. So let's look at the i.MX range in some more detail. Thank you very much. As you can see, the i.MX, there's many parts. If we go back to the i.MX 6, this was first launched in 2012, but based on the ARM v7 technology. That portfolio, as you can see, stretches from a quad core down to a single core. That was started to ship in 2012, and it will be it's already been extended until 2035. So Tafiq mentioned at the beginning that longevity is one of the keys for iWave's market. It's the same with us. We realize that the markets we go into, 5 years, 10 years is often the starting point, and therefore we make sure that our processors are focused on being available for the long term to meet your product needs and their life cycles. The other common element across all of our parts is that they have the same software. We have one board support package, be it Linux or Android, across the entire portfolio. That's what we started with the i.MX 6. And then as we transitioned to the ARM 64-bit with the V8 architecture, we carried on that position in that we have the same software BSP. Pin-to-pin compatibility was achievable with the i.MX 6s from where we were in the market and the IP that we were integrating with the i.MX 8s. That begun to be more difficult across the entire family, but you will find pin-to-pin compatibility within families of the 8 family. The i.MX 9, which is the focus of the presentation today, was first announced a couple of years ago. The i.MX 93 was launched officially in Embedded World this year in March, and will be in full volume production in the next couple of months and are available through key partners like iWave right now. We did announce the i.MX 95 at the beginning of this year and the i.MX 91 a couple of months ago at Computex. So just like the 6s and the 8s, the i.MX 9 family will be built out to really meet the entire needs of your end customers, to really look at the diversity of the markets and make sure that we evolve and bring cutting edge technology to you, be it for graphics or machine learning. What we're not changing is the core values that we established with the i.MX 6, which is we will have the same Linux, Android, BSPs running across the entire family. We're also now working closely with Microsoft in terms of Windows 10 Enterprise, which are currently available on the i.MX 8, and will transition to the i.MX 9 family as well. So let's go to the next slide and have a deep dive on the i.MX 93, which is the focus of the presentation today. So if you look at the i.MX 93, if you look in the bottom left-hand corner, as I just said, it's part of a scalable family. We never come out with a point product because we realize one size does not fit all, and your customers and you have a need for a scalable portfolio which is looking at different solutions and different customer usage models. The main difference between the 93 and the i.MX 8 family is we've transitioned from an A53 to an A55 core. What is an A55 core from ARM? Well, really, we believe it's ARM's most efficient 64-bit Cortex-A core. If you compare it to the A53, you're looking, depending on implementation, but a very high level, you're looking at about a 20% improvement in integer performance, about a 30% floating point performance apples to apples comparison for different for the same implementation and usage model. Really, we planned, as we evolve the i.MX 9 family, we plan to utilize the A55. That obviously makes our life easier from maintaining a single BSP. But we also realize that that will make it easier for you to maintain and update your products once they are deployed into the field. In terms of essential connectivity, we realize that the diverse needs of the market. We haven't forgotten that as we look at the 9, that is still a core tenet of the industrial and IoT markets. So from a connectivity standpoint, in the 93, you have 2 USB 2.0, up to 8 UARTs, 8 I2Cs, and a wide range of other connectivity options. In terms of gigabit Ethernet, you have 2 gigabit Ethernets, one which is TSN enabled and 2 CAN FDs, and then a range of eMMC options and optical SPI flash. One of the things which is also common that we've carried on from which we started in the i.MX 6 family is the heterogeneous architecture, where we realize performance and overall capabilities is extremely important, but also the ability to take the part and run it in a very low power mode. We've continued to integrate an MCU in the 93. It's an i.MX 33 running at approximately 250 megahertz. What this does, obviously, it enables you to look at running a low-level interrupt, a specific software stack such as a Bluetooth stack, in a much low power profile than you would have if you were engaging on the A core. To really optimize the ability to run the 93 in a low power mode, we also have implemented what we call the Energy Flex architecture, which is on the left-hand side of the slide. And this is the ability to run each domain independently and power off the rest of the product. So for example, we have a real-time domain, which includes the low power core that I just mentioned, the M33, and all the peripherals connected to it to enable background processing, such as I mentioned, but also, for example, wake word detection, not just voice, but also sound, to wake up the system without powering on the A cores if you don't need to. Moving along, inherently intelligent refers to the fact that the 93 does include a neural processing unit, an NPU, which was referred to in the title of this presentation in terms of machine learning. If you look at the 8M family, we did integrate an NPU for the first time in the 8M Plus. We are looking at the needs of our users in terms of machine learning. And really, with the i.MX 9, is designed to enable customers to take advantage of the machine learning, but implement it as easily and efficiently as possible. So you might get caught up and look at the number of TOPS and think what is needed, but really we're looking at the implementations we're seeing, which are much more anomaly detection, vibration, which are looking for much more efficient power usage and efficiency when it comes to machine learning, and I'll go into a little bit more detail there. In terms of the multi-sensory experiences, we have many IP with connectivity options and I/O expansion, which we're trying to enable a wide range of usage models, from vision, utilizing the NPU that I just referenced, to voice, where you can use the MCU for the M33 for wake word detection. And then we have an updated audio block with I2Ss and TDM interfaces to enable 8 channels of digital mic inputs. So really are trying to make sure that we have everything covered from a usage model perspective. High performance and connectivity are what we believe, you as customers and our key partners such as iWave need to build industry leading edge devices, but these need to be delivered with intelligent security. So the last IP block I'm going to talk about is the EdgeLock Secure Enclave. The EdgeLock Secure Enclave is a pre-configured self-managed and autonomous on-die security system. What does that mean? It means that really what we're trying to do is to pre-configure and help ease the complexity of implementing robust system-wide intelligence security, and so avoid costly errors that might occur once you deploy the device. So as I mentioned, the secure lock is fully integrated and built in to the i.MX, all of our i.MX 9s. And what we're looking to really do is to provide scalable options for you to deploy security to a minimum number of edge devices or thousands of edge devices, stretching from wearables in the consumer space to industrial automation and smart factory. We're doing that with a range of security features, which allow you to do key management, key attestation, and really create a silicon root of trust without having to use a separate device on the board itself. So really that's a whirlwind tour of the i.MX 93, and Trafiq will probably go into more details on how iWave have taken that. But I just really want to touch on the NPU, the neural processing unit, which is integrated as this title was around machine learning. So as I mentioned, we have integrated the Ethos U65 from ARM. We did that because it's a very highly efficient and small footprint NPU, as opposed to some of the other NPUs that are out there that require a large amount of memory and performance to really work efficiently as a vector graphics engine. We're really looking to give you the options to run that, and also to run operations if necessary on the Cortex-M or the Cortex-A core. And really what the U65 brings is, the ability to run compressed models and on-the-fly weight decompression, optimized implementations for both DRAM and SRAM, utilizing the M core and the A core. And also what we realize is hardware is only part of this solution here. And so we provide comprehensive software and tools with NXP EIQ machine learning software development environment. So what is EIQ? If we go to the next slide, we have a summary of a very complex and capable software ecosystem, which we've really wrapped up to make it as easy as possible for you to start understanding how to really leverage machine learning and what we provide to enable your device and your customers to meet all their needs as evolving needs of machine learning. So the EIQ machine learning software development environment includes the toolkit, an easy to use machine learning workflow, which is a tool designed to ease your overall machine learning development. The EIQ, it enables graphic level profiling capabilities, runtime insights, and the ability to optimize neural network architectures. And so really it's a very powerful tool. One of the most important things, which I forgot to mention, is that the baseline enablement is offered as no additional charge. So if you utilize the iWave's SoM or single board computer based on the i.MX 93, you can then download EIQ from the NXP website and utilize this for your needs. If you have your own data, that's great. If you already have a model, you can import that as well. So we're really trying to make sure that we enable all the IP that we put into our SoC that iWave turns into a cutting edge device for you. So having gone through this, where does it leave us in terms of markets, which we can go after with the which we are focused on with the i.MX 93? And so we've talked a lot about vision in the last couple of slides. So obviously the key feature that I focused on was the neural processing unit. There's a number of camera options in the 93 in terms of MIPI CSI 4 lanes to allow you to get data into the device. And really this wide range of features and functionalities that I've gone through makes it applicable to a wide number of markets, from automation and the key industrial markets such as medical, transportation, mobility, which i.MX has an iWave both have a deep customer base in. It's also made the vision, the NPU, the MIPI CSI, the Wi-Fi connectivity, the overall connectivity I mentioned really makes it also applicable to smart homes, smart cities, and then also automotive, as automotive really looks to, in terms of the base needs, converge with industrial. We're really seeing the 93 in some of the automotive usage models as well. However, whatever we do is only the starting point. We need key partners that can take our SoC, create board level devices around it, and that's why we work very closely with iWave. So what I'll do now is I'll hand it back to Tafiq, who can tell you what iWave have done with the i.MX 93.
Thanks, Robert. That was a wonderful introduction on the i.MX 93, and based on the features we have seen, the i.MX 93 and the IPs built into the SoC definitely accelerate machine learning. And as iWave, we work with NXP to empower this edge intelligence on solutions across the applications which Robert just mentioned, ranging from vision to smart home, automotive. There is no application vertical without AI today. So how do we enable product development for these AI solutions? So we have launched what we call as the IW Rainbow G50M, which is a system on module powered by the i.MX 93 applications processor, where we have integrated memory, which goes up to 2 GB LPDDR4 RAM, integrating up to 128 GB of eMMC memory. And a key block is the Wi-Fi 6, Bluetooth, and the Thread wireless connectivity module on board. And one of the key value proposition of this module is the very compact form factor. So as you can see, the system on module is built on a 45 by 45 form factor, which enable very compact products for your gateways, or in terms of your smart cameras, which have a strict restriction on the size. This forms as a key building block. And we have the complete industrial grade support, so making sure that the product works across the complete temperature range and is prone to shock, vibration, taking care of the environmental characteristic, and also supporting the latest of Linux and the other operating systems provided by NXP. We ensure that the same is available on our i.MX 93 system on module as well. So we were an early access partner with NXP for the i.MX 93, i.MX 9 application portfolio, and we continue to support customers, and have also started shipping out samples of the system on module and the evaluation kit. And as you can see, we have enabled all interfaces starting from MIPI CSI, MIPI DSI, LVDS, CAN. So different kinds of applications starting from industrial automation to graphic solutions, or maybe say video analytics. So different kinds of applications can be enabled based on the different interfaces available on the system on module. And there are some customers who also have the i.MX 93 requirement in a SODIMM form factor. For example, your Ethernet gateways, industrial automation gateways, where they require a SODIMM form factor. So which is where we, apart from the OSM standard, we also have it in the SODIMM standard, and we will be launching this in Q4 this year. The interfaces would remain the same, is more in terms of the form factor and the different kinds of wireless connectivity options on module. And as I mentioned, so for example, the MIPI CSI brought out on the system on module enables you to connect a camera with maybe say up to 1080p at 60p interface, where you can leverage the onboard NPU to support the different kinds of monochrome and color applications with the i.MX 93 SoC. And the second is you have the display interfaces. You have the MIPI DSI and LVDS, and where the i.MX 93 provides the 2D graphics processing capabilities, as well as when you combine it with the low power features, you can have such AI applications where you require video analytics as well as the graphical display requirements. Coming to the industrial automation, where you require the CAN and the gigabit Ethernet. So we have the CAN gigabit Ethernet signals available, and you also can leverage the low power modes and the M33 core to have such sort of industrial automation, industrial AI, edge gateways, and different types of AI requirements and different varying requirements. So this as Robert mentioned, the key building blocks of i.MX 93. So these are the other key IPs which make the i.MX 93 SoM a key building block and a perfect fit for your AI product. The first being a cost efficiency. So definitely the system on module needs to be cost effective. The rising scale of AI products and the importance of driving down price. So iWave has made sure that we are able to provide you the i.MX 93 system on module at the lowest cost, starting from $49 onwards. So we make sure that the system on module is not a price hindrance for your AI solution. The second is the integrated NPU on the i.MX 93 SoC, where we have the ARM, the U65 micro NPU, where you have efficient machine learning. And it's not only the NPU, but also the different types of the software models, as Robert mentioned, the EIQ software that comes integrated with the SOM. And the third point is in terms of power efficiency. So here is where you have the two A55 core, you have the M33 core. So you can utilize the M33 core to have a sort of low power modes, and also the integrated energy flex architecture that has been integrated. So you have the individual control of the power and clock frequency of the different domains. You have the A55, the M33, as well as the NPU domain. So you have the different domain control where they can really optimize the low power modes and the power efficiency for your edge AI solution. Then the next, there is no AI solution without security, because security has also been rising in terms of importance in solutions across the globe. So with NXP's EdgeLock Secure Enclave, you have a ready-to-use solution. So different types of security functions like root of trust, runtime attestation, trust provisioning, secure boot. So you have different types of key management solutions and cryptographic services such as like the random number generator, and as well as managing the signed images, the PKA, the systems. So you have all these blocks built into the i.MX 93, which enables you to quickly utilize these modules and have a secure AI solution. And all these secure modules come built in with the BSP support, which ensures that you don't spend much time having a separate secure element, having a separate security software service. All this come to you ready as a ready to use plug and play solution. And last but not the least is in terms of compactness. Yes, you can have all of them, but you cannot have a big solution which doesn't fit into your gateways, doesn't fit into your edge cameras, doesn't fit into your smart home hubs. So which is where you also require compactness. So this is where the IW Rainbow G50M from iWave, where we work very closely with NXP, and I've launched this product targeting towards the AI segment for the industrial, automotive, vision, different types of application requirements coming up right now. So in terms of software, yes, we have a production ready OS. So in terms of working with NXP, in terms of their Linux BSP, as well as have a continuous product update in terms of software update roadmap. So as Robert mentioned, in terms of Android support or Windows support, Windows 10, Windows IoT support. So different kinds of operating systems as well, for example, Linux running on the A55 core or FreeRTOS core. So we make sure that the complete Linux BSP is available for any customer who purchases the SOM or the evaluation kit. And what iWave does is we also customize the system, the software update depending on different driver requirements from customers, and make sure that this software update is supported for a period of 10 years. So in tandem with the hardware build, we also make sure that the software availability is provided by iWave for the complete product longevity program. So as an early access partner, we were able to launch evaluation kits, and we have the evaluation kits ready for purchase on Mouser and DigiKey. And together with the evaluation kit, we also completely provide you the complete technical support. So reference design files in terms of the schematics of the carrier board, and once customers start getting used to the system on module and start building their own carrier board, iWave also supports them in terms of the complete layout review, and ensuring that their product goes to market faster. So we do not stop at selling the evaluation kit, but we also handle the customers starting from the schematics review to the layout review to the complete production cycle. So do contact us in terms of if you're not able to find out, do contact us at the below provided ID, and we'll be able to help you with evaluation kits at the earliest. And now going to the next phase of this webinar, which is the OSM standard. So the OSM standard was definitely launched as a standard for the low cost embedded compact modules in a compact form factor. So as I previously mentioned, it is a very compact form factor with 45 mm by 45 mm at the largest. So here the OSM standard defines 4 form factors, what you can see on the left hand side: the size 0, the size small, the size medium, and the size large. So these 4 form factors build upon each other, and you can have a solderable module. So just another chip. This system on module is just another component that can be pick and placed by any assembly machine. And now comparing it with the previous standards of SMARC, QSN, or Solderable. So if you see the pin to size area, the ratio of the pin to size, you can see that the OSM standard offers you a lot more compactness and provides you the scalability option. And depending on your product requirements, you can choose which size is compatible for your product, which I'll touch upon the next slide. So as you see, there are 4 form factors that build upon each other. So we have four sizes: the zero, size, small, medium, and large. So how do you take a call on which size you need to go for your product? So definitely a decision has to be taken on the interfaces required for your application. So if you require an LVDS signal, only the size large supports the LVDS interface. And if you require the Wi-Fi and the Bluetooth connectivity on board, you require the size L, where all these modules are available on the system or module, and different types of RAM and memory on the module. So there are different the system or modules are available from this size 0 to size large onwards, and it is dependent on your product requirements. The interface is available, the real estate available, so where you can choose an application, the module dependent on your application. And how do you solder these system on modules? So it is not like any of the previous modules where you plug it into a connector. That is one key value of the OSM module. So you have 3 different technologies which are available. So you have the fused in grid array package, the ENIG LGA package, and the BGA package. So it is dependent on the manufacturer, dependent based on their choice on what type of contact soldering mechanism or technology they want to go forward with. And at iWave, we support the LGA package across the complete portfolio, the i.MX 93, the i.MX 91, and the 95 as well coming up next year. We will make sure that the system on modules are scalable. So the scalability NXP provides across the portfolio, we will ensure that the same scalability is available on the system on module as well, which ensures that you have that sort of an option to always scale up your technology in your product in the near future. So how do you build your carrier card PCB? So some system there are 2 types of provisions which are called the standard height and the extended height. So the standard height, suppose you have the system on module with components only on the top of your system on module, you can go with the standard height, where the system on module is plugged on directly to the carrier board, is soldered onto the pads provided. However, if the system or module also has components on the bottom, you need to provide what is called as a spacer PCB, what you see on the right hand side. So with the spacer PCB, you then mount your system on module, the OSM SoM, onto the spacer PCB to provision for the components on the bottom side of the PCB. So when you are designing your carrier card, it is best to take into consideration the PCB spacer requirement and ensure that is included in your carrier card design. And to summarize, I would say here are 5 key questions you need to answer when you are designing your product with an OSM system on module. So the first question is choosing a spacer PCB versus a carrier cutout. So what type of spacer PCB, what types of system on module do I go for, and does it have components on the bottom? The second is provision the cutout for different form factors. So for example, you go for a size 0 or your size small, and if you make sure that if you are convinced that that suffices your requirement, what we at iWave would suggest is you make the carrier card to support the size L standard, and you can always be backward compatible. So make sure that your carrier board has the provision for size L and then you can always include a size 0, a size small, a size M, or a size L. All of them are compatible with your carrier card. And then as the OSM standard also defines an RF antenna location. So as you see on the in the middle, the 4.5 mm by the 15 mm, that is provisioned for your RF antenna characters. So please account for the different types of RF antenna location and the breakout area of the system or module. And just as other form factors, the OSM does not have the provision for the heatsink on module. So while designing a carrier card, you will have to account for the provision of heat sinks, the screws, and the heat spreaders onto the carrier cord, which I will cover up in the next slide. And also thermal hotspots to be taken care with the corresponding heat sink or the heat spreader. So these are the considerations from a thermal aspect. So the OSM modules are small, so definitely you need to account for the screw holes for the heat sinks or the heat spreaders onto your carrier card and make sure that they are completely accounted for the heat dissipation from the OSM system on module. And with a lot of components on the OSM system or module, you need to make sure that they all are accommodative of the different heights of the different components. And we suggest going for a screw and spring mounted heat sinks since the mounting holes are provided on the carrier card. And when compared to other standards, the OSM modules based on our power analytics, the OSM modules are perfect to cool since they have a larger surface area of the carrier card. Because of the compactness of the SoM, you have more space on the carrier card. And with the complete directly soldering the different pads, there's definitely a more thermally conductive part for the thermal efficiency. So there are both pros and cons from a thermal perspective, but with the heat sinks and heat spreaders, you can account for this on your carrier card design. And yeah, so I have spoken on in terms of the advantages to OSM, how it is going to be a key OSM SoM standard in the years to come, the next 10 years to come. But there are a few challenges. How do you account for RMA on the field? Or how do you program your OSM module in production? So there are and how do you test in production? For example, your Spark and Q7, you could insert it into an evaluation board, or you could insert it into an evaluation test jig, flash a software, or do the complete debugging. But this is not possible with the OSM system or module, since it has to be soldered onto an evaluation kit, and you cannot solder and desolder. So there are three challenges with the OSM system or module. However, there are solutions that are coming. So this standard was launched in 2022, and we have been working, and iWave has been working with different manufacturers across the globe. So to make sure that these solutions are being resolved. So we have a socket, a test jig where the system on modules can be inserted and need not be soldered, but is just plugged on to the what we call the pogo pin connector. So you can just plug it in and test it through the complete test jig and the socket. And what we also have is a complete JTAG and console header on SoM, where you're able to easily flash the software. So the RMA, the production related, the software related, in production, the aspects are getting resolved. And definitely the challenges faced with OSM in the last 18 to 24 months is definitely being erased off. So coming to definitely the last question of why iWave for system on modules. So these are the 5 key value proposition from iWave, right? So we have an extensive portfolio, right? So as I mentioned, so you have the i.MX 9.3, we'll have the i.MX 9.1 coming up in a few months, the i.MX 9.5 plan next year. So we make sure that you have a very dependent product requirement. So it's dependent in your cost, interface requirement, your processing requirement. You have the complete portfolio, and because of our extensive portfolio and software support, we make sure that the best of support is available for customers. The second is in terms of product longevity. So in tandem with NXP, we make sure that for the industrial, automotive, medical programs, we make sure that the system on module is available for a minimum of 10 years, all the way going to 15 years, starting from the hardware as well as the software, so that customers can ensure that this product is not going to go off the market in the near future. The third, we are not only a SoM vendor, but as well as complete the SoM, the test jig, the single board computer, extensive technical support in terms of layout review. We make sure that you have the complete technical team to provide you the complementary expertise. The fourth, we have a very extensive production ecosystem. So manufacturing in Japan, North America, and Taiwan, which we have been able to leverage upon and make sure that the best of production facilities are available to customers, and making sure the shortest of lead times are available for customers. And last but not the least is we have a global distribution ecosystem. So any part of the globe, we have the right distribution ecosystem to make sure to help you in your product selection journey, to have to speak in your language, and to help you in your logistics fulfillment. We have the distribution ecosystem. So with these 5 blocks supporting iWave, we make sure that iWave can be a preferred SoM partner. We have been helping customers over the last 15 years, and have also emerged as a global SoM vendor across the globe. And as I mentioned, so we do not want to be a key SoM vendor, but starting from ideation all the way to certification in terms of SEC, CE, and complete end of life maintenance, we want to handle customers from ideation to production, from qualification, whether it's your mechanical aspect or your thermal aspect. So this is a broad range of expertise we support in tandem with the system on module and the single board computers. So we want to make sure that the latest of technology from NXP, where they have integrated different types of IP, starting from power efficiency, the NPUs, the ARM instruction sets, the latest of ARM technology. So enabling this at the shortest span of time, and which makes you go to market faster with reduced costs and risk. That is where iWave comes in and plays a role together with NXP. And now that brings me to the end of my presentations, and will be happy to answer any questions you may have right now.